colleagues, they'd head off to the formal meeting at the Institute, and somehow every night by supper time, Bohr would have an answer. One of the observers said that Einstein was like a jack-in-the-box. Every day he'd pop up with a new challenge, and Bohr would flip this way and that, and then by supper have crushed that one, and it would start all over again.
To Bohr and his colleagues, quantum mechanics not only explained experimental results, its mathematics were elegant and beautiful. And since Einstein hadn't found flaws in their equations, they left the Solvay meeting feeling more confident than ever in their ideas. But Einstein didn't give up his conviction that quantum mechanics was flawed. And in his refusal to accept the weird implications of the theory, he would wind up uncovering something even weirder. In 1933, with the Nazi Party in power in Germany, Einstein chose to settle in America and took a position at the Institute for Advanced Study in Princeton, New Jersey. He recruited two physicists to help him, Nathan Rosen and Boris Podolsky. And in 1935, at afternoon tea, the three men spotted a possible flaw in quantum mechanics that would shake the very foundations of the theory. They noticed that the mathematics of quantum mechanics led to a seemingly impossible situation. Today, Robert Dijkgraaf is the director of the Institute.
Apparently Podolsky said, well, Professor Einstein, this is very important in your arguments showing that quantum theory is incomplete. So they got this very animated discussion, and what kind of happens still is now you have a bunch of scientists discussing, and at some point someone says, let's write a paper together. So they did.
Their paper, known today as EPR, argued that the equations of quantum mechanics predicted an impossible connection between particles, a seemingly magical effect. It would be like having two particles, each hidden under a cup. Looking at one mysteriously causes the other to reveal itself too, with matching properties. Quantum theory suggested this effect could happen in the real world. For example, with particles of light, photons. The equations implied that a source of photons could create pairs in such a way that when we measure one, causing it to snap out of its fuzzy state, the other mysteriously snaps out of its fuzzy state at the same instant, with correlated properties. The 1935 paper that described this effect has become Einstein's most referenced work of all. It has captivated generations of physicists, including Anton Zeilinger.
The Einstein-Podolsky-Rosen paper fascinated me, and I had to read it at least 5 or 6 times until I finally understood what goes on. And then it didn't let me go again.
Another way to think of the paired particles is to imagine a game of chance that's somehow rigged.
Suppose I had